Good evening. We start with sum number 18. Let L be the limit. Limit extends to 1. 2 raised to 2x minus 2 minus 2 raised to x plus 1 upon sine square x minus 1. As usual, we put x equal to 1 plus h. As x tends to 1, h will tend to 0. Right down. So this becomes limit h tends to 0, 2 raised to 2 into in bracket 1 plus h minus 2 minus 2 raised to 1 plus h plus 1. Now x is 1 plus h. So it is x minus 1 h. So denominator becomes sine square h. So this becomes limit h tends to 0, 2 raised to 2h, because if you open the bracket, 2 plus 2h minus 2 means 2h. Note that 2 raised to 2h is square of 2 raised to h, right? So numerator is now perfect square of 2 raised to h minus 1, denominator as it is. Now next step is obviously divide numerator and denominator by h square. So we get limit h tends to 0, 2 raised to h minus 1 square by h square upon sine square h by h square. Limit of square is square of limit. This is standard limit. Its value is log 2. So log 2 bracket square upon, this is standard trigo limit. Its value is 1. So 1 square. This is the final answer. Now you should write reason for this. Why can we divide by h square? Because h only tends to 0. H is not equal to 0. And here you have to mention that standard limit x tends to 0, a raised to x minus 1 upon x equal to log a is used. Actually 19th is similar to 18th. Here you have to put x equal to 1 plus h. So function becomes, see, this is hint, this is not the solution. Otherwise I would have written limit every time. So 4 raised to h minus 2 raised to 1 plus h plus 1. Numerator is square of 2 raised to h minus 1. Denominator is h square. Yes, answer is again the same, square of log 2. Sum number 20. Let L be the limit. Limit extends to 1, root x minus 1 upon log x. Now some students may say, sir, we will put x equal to 1 plus h immediately and then we will rationalize. No problem. But here first I have rationalized numerator. What is the advantage of that? See, though we say rationalizing numerator, we have to multiply denominator also by that rationalizing factor, right? So in the next step, see what I have done. Limit of product is product of limit. For this, limit can be taken directly provided we write this separately. This is not allowed. That take limit of this part and this is x minus 1 upon log x. Not allowed. But now I can. So there was actually no need to replace this x by 1 plus h, right? And therefore in the next step, I'll take this limit and then I will put x equal to 1 plus h. So this is 1 upon 2 because this is root 1 plus 1. So 1 upon 2. Now put x equal to 1 plus h. As x tends to 1, h will tend to 0. So limit h tends to 0, h upon log of 1 plus h. Divide numerator and denominator by h. So 1 upon h log of 1 plus h. Now what is the next step? So this is 1 by 2. Okay. Into, see what I'm doing, 1 upon limit h tends to 0. Now what is n log m? Log of m raised to n. So log of 1 plus h raised to 1 upon h. Now what is limit of log? Log of limit. So it is 1 upon 2 into log of limit h tends to 0. Okay. 1 plus h raised to 1 upon h. The next step, this is 1 by 2 into 1 upon, this is standard limit, its value is e. So it is 1 upon 2 into, what is log e? 1. So 1 upon 2 is the answer, final answer. Okay, see in the next sum, we are going to use this fact, n square, see, Can I replace n square by 1 plus 3 plus 5 up to 2n minus 1? The answer is yes. See, sum of the first n odd numbers 1 plus 3 plus 5. So these are in AP. First term 1, common difference 2. So n by 2 into 2a plus n minus 1 into d formula is used. So this is nothing but n square. See how we can use this in sum number, I think 22. Yes. Limit x tends to 1. Let me explain. X plus 3x square plus 5x cube up to 2n minus 1 x raised to n minus n square upon x minus 1. This n square is replaced by 1 plus 3 plus 5 up to 2n minus 1. This is nth odd number, right? Now this actually all these are negative when we open the bracket. So x minus 1, 3x square minus 3, 5x cube minus 5, and so on, right? And therefore you can see this one. Split numerator, x minus 1 upon x minus 1. Before that, take 3 common from these two terms. So 3 into x square minus 1 upon x minus 1 plus 5 into x cube minus 1 upon x minus 1 up to what? 2n minus 1 into x raised to n minus 1 upon x minus 1. Now you know standard formula, standard limit. This one answer is n into a raised to n minus 1. See, limiting value is 1. So 1 raised to is going to be 1 only. So answer is n. Means what? Here index is 1. So this is 1. Here index is 2. So 2, 3 and so on. So you will notice that in the next step it is 1 into 1 plus 3 into 2 plus 5 into 3 up to what? 2n minus 1 into n. Now we have done sequence and series. So using sigma notation, I can say that this is sigma 2r minus 1 into r. R goes from 1 to n. You may ask me, sir, can we write sigma 2n minus 1 into n, n goes from 1 to n? Yes. But instead of saying n goes from 1 to n, why not to write TR, right? Because Sn is sigma TR, R goes from 1 to n, and then the same thing. Open the bracket, 2r square minus r. Sigma of difference is difference of sigmas. Sigma of constant into variable is that constant. Sigma of variable. Now it is sigma r square. N into n plus 1 into 2n plus 1 upon 6. What is sigma r? N into n plus 1 by 2. Simplify patiently to get final answer as what? N into n plus 1 into 4n minus 1 upon 6. Is that clear? Yes. See, the topic is limits and what is required? Knowledge of sigma notation and of course standard sums. I mean sigma r square, sigma r cube is not required, but you should all know all these things. Sum number 23. Let L be the limit x tends to 0, 1 upon x raised to 12 into in bracket 1 minus cos of x square by 2 minus cos of x raised to 4 by 4 plus cos of x square by 2 into cos of x raised to 4 by 4. Actually, I have omitted one step. You should write this as, put this in bracket. Take minus cos of x raised to 4 by 4 common to get again same thing in bracket 1 minus cos of x square by 2. Take that bracket common. So what is numerator? This is numerator, denominator as it is. Now you may say, sir, we have 1 minus cos, so we will multiply by 1 plus cos. Yes, but here to I won't say avoid confusion because this is again not difficult. 1 minus cos theta is what? 2 sine square theta by 2. See, this is not cos square. Square is in the angle. You have to be careful. So this becomes what? 2 sine square x square by 4 because theta becomes theta by 2, half. And what about this? 2 sine square x raised to 4 upon 8. See what you get. So this is limit x tends to 0, 2 sine square x square by 4 upon, see, First we write what we want. Okay, actually angle must be fully repeated, so x square by 4, but it is sine square, so square of this. So in the process I have multiplied denominator by 1 by 4 square, so I multiply numerator also by the same logic is to be applied here also. X raised to 4 upon 8 should be the denominator, but it is sine square, so square of this, and that is why 1 upon 8 raised to 2. Let us check whether we have written same term x raised to 12 in the denominator or not. Laws of indices, x square raised to 2 is x raised to 4 into x raised to 8. Yes, x raised to 4 into x raised to 8 is x raised to 4 plus 8, that is x raised to 12. Yes, original x raised to 12. So we have written the same. Now next part is simple. Constant term is to be written outside the limit. So 2 into 2 upon 4 square into 8 square. Simplify this. So this is what? 1 upon 256. Limit of square is square of limit. Right? Sine square x raised to 4 upon it. It is better that we put fractional angle in a bracket. Okay. Oh, I'm sorry. Now this is correct. Yes. So this is 1 upon 256 into 1 square into 1 square. You have to write the reason as x tends to 0, both angles, x square by 4 and x raised to 4 by 8, both tend to 0, and with standard limit y tends to 0, sin y upon y is nothing but 1. Okay, so final answer is nothing but 1 upon 256. Now the 24th sum, actually this type is not there in the syllabus, but still they have asked this sum. Here we take limits of base and index separately. See, this is the base which is denoted by fx and index is denoted by gx. Now what is limit of base? Same, that method is the same. Limit extends to infinity, fx of this, divide numerator and denominator by x square. Okay, now limit of 1 upon x and 1 upon x square as x tends to infinity is 0. So it is simply what? 8 upon 2, which is nothing but 4. Okay, see, 4. Then limit of index, that is also can be obtained easily. Divide numerator and denominator by x. So this is 4 upon 8, that is half. So what is the value of limit? See, limit of this function is limit extends to infinity fx raised to gx, because we have denoted the base by fx and index by gx. This is nothing but limit extends to infinity fx raised to limit extends to infinity gx, which is 4 raised to half, because we have already obtained these two separately. Limit of base is 4 and that of index is half. So 4 raised to half, that is 2. So value of the limit is 2. Now we are going to discuss an important concept of neighborhood. Just listen to me. Let A be any real number. The set of all real numbers x such that a minus delta less than x less than a plus delta. And what is delta? Delta is very small but positive real number. I repeat, delta is a small but positive real number. Then this is called as delta neighborhood of A. I repeat, this is called as delta neighborhood of A. Delta neighborhood of A. Neighborhood in some cases is written in short as NHBD, delta neighborhood of A, right? Thus, the delta neighborhood of A is an open interval. See, I can say that X belongs to open interval A minus delta, A plus delta. What is the length of this open interval? It is 2 delta. And clearly, what is the midpoint of this? It is nothing but A. See, this is number line. This is A. Okay. This is A minus delta. As it is an open interval, it doesn't belong to that interval, right? And this is A plus delta. What is the midpoint of this? It is nothing but A, because this much is delta and this much is delta. I can say that length of the interval is 2 delta. Okay. Hence, delta neighborhood of A is the set of points on either side of A, and that is why the word neighborhood is used. So some neighbors are to the left of A and some neighbors are to the right of A. Okay. Yes. Can I write this as mod of x minus a less than delta? Yes, we can, because we have already discussed that this is nothing but minus delta less than x minus a less than plus delta. I repeat, when I say that modulus is less than delta and delta is positive, then minus delta less than x minus a less than delta. Add a, so that is a minus delta less than x less than a plus delta. See, I have written the same thing. Okay. So delta neighborhood of A can also be written as mod of x minus a less than delta. Okay. Suppose I omit a from this. From what? From this neighborhood. So if I say the set of all points x, the set of all points x belonging to open interval a minus delta, a plus delta, except x equal to a, will be called as what? It is called as deleted neighborhood of A. Now you will ask me, sir, why to delete this? Because we use this to define the concept of limit. So this is deleted delta neighborhood of A, and therefore we can write this as 0 less than mod of x minus a less than delta. Why? Because it is rather A is omitted from this. In short, neighborhood of A is an open interval A minus delta, A plus delta, where delta is very small but positive real number. So if I ask you, let me explain first, then if you have any difficulty, you can ask me. What is 0.02 neighborhood of 3? Can you write that? Yes, it is an open interval a minus delta, so 2.98, and a plus delta 3.02. Yes, this is nothing but 0.02 neighborhood of 3. And what is deleted neighborhood in this case? So I can say that x is a real number. X belongs to this particular interval, x not equal to 3. Okay. I hope you have understood this. Now, see, while solving problems initially, we use simple definition. We never used the concept of this neighborhood. We never used epsilon delta. but now this is the real definition of limit. If we can bring f of x as nearer and nearer, very close to L as we like, by taking x sufficiently close to a without taking x equal to a, then limit extends to a f of x equal to L. I remember I have told you that uh, as x assumes values which are nearer and nearer to a, f of x assumes values which are nearer and nearer to L, then L is called as limiting value of the function fx as x tends to a. Now, as we know the concept of this deleted neighborhood, see why deleted? Because when we say x tends to a, x is not equal to a. I hope you have understood this. That is why deleted neighborhood. Okay. So limit of fx as x tends to a equal to L, if for given epsilon greater than 0, there exists delta greater than 0 such that mod of fx minus L is less than epsilon whenever 0 less than mod of x minus a less than delta. Now you will ask, sir, we have understood delta, but what is this epsilon? Epsilon is again a very small positive number. So I'm saying that this modulus value is obviously non-negative, right? And it is small, it is rather, it is smaller, it is less than epsilon, where epsilon is greater than 0. Now we will solve four sums which I think we haven't done before. Exercise 7.1, fourth part. In the following examples, given epsilon greater than 0, find delta greater than 0 such that whenever mod of x minus L less than delta, we must have mod of fx minus L less than epsilon. See what is fx? Fx is the function whose limit value is to be obtained. What is L? L is nothing but value of the limit. What is A? A is nothing but tending value of the variable which is usually x. What is epsilon and delta? Epsilon and delta are small positive real numbers. So let us discuss this. Limit x tends to 2 of 2x plus 3 is nothing but 7. So what is fx? 2x plus 3. What is a? Tending value, that is 2. What is L? Value of the limit, 7. Let epsilon be greater than 0. Consider mod of fx minus L less than epsilon. Substitute the values. So mod of 2x plus 3 minus 7 less than epsilon. That is 2x minus 4 less than epsilon. Can I take 2 common? Yes, I can. Now 2 is positive, so I can write it outside the modulus. Divide by 2. So mod of x minus 2 is less than epsilon by 2. Now I can replace epsilon by 2 by delta because epsilon is positive. So epsilon upon 2 is also positive. It can be replaced by delta, right? So I can say 0 less than mod of x minus 2 less than delta. And therefore it implies that mod of fx minus 7 is less than epsilon. Now you will ask me, sir, what is the significance of this? See, significance of this is the same, that the limit can be written in this form, that limit extends to a f of x equal to L. I can say that in that case mod of fx minus L is less than epsilon, right? Where epsilon is greater than 0, delta is greater than 0, and here 0 less than mod of x minus a less than delta. Okay. So in the second sum, limit extends to minus 3, 3x plus 2 is minus 7. So this is fx, this is a, this is L. Let epsilon be greater than 0. Let this be given. Consider mod of fx minus L less than epsilon. Substitute the values. 3x plus 2 minus minus 7. So plus 7 means 3x plus 9. Take 3 common. Now 3 is positive, so I can write this as 3 mod of. Now x plus 3 can be written as x minus minus 3. Why to write like this? Because a is not 3 and we need x minus a, and a is minus 3. Simple. Now epsilon by 3 is again positive. Suppose it is delta. Now this can be written as 0 less than mod of x minus in bracket minus 3 less than delta. Right? So this is about second sum. After this, we have to say this implies mod of fx minus minus 7 less than epsilon. Third one, limit x tends to 2, x square minus 1 equal to 3. Here fx is x square minus 1, a is 2, l is 3. Let epsilon greater than 0 be given. Consider mod of fx minus l less than epsilon. Substitute the values. So this becomes mod of x square minus 4. What are the factors? X minus 2, x plus 2, right? Less than epsilon. Now mod of x minus 2 into x plus 2 is what? Mod of x minus 2 into mod of x plus 2. Note that tending value is 2 only. So x is very close to 2. And therefore modulus of x plus 2 is definitely greater than 1. And therefore I can say mod of x minus 2 is less than epsilon. Now I say that let epsilon be delta only because both are positive real numbers, they can be equal. So if I say mod of x minus 2 is delta, I can write this as 0 less than mod of x minus 2 less than delta. Implies mod of fx minus 3 less than epsilon. Okay. So this is about sum number 3. Try sum number 4. I'll give some time. Fourth one, limit x tends to 1, x square plus x plus 1 equal to 3. Now what is fx? X square plus x plus 1. What is a? 1. What is l? 3. Let epsilon greater than be 0 be given. Consider mod of fx minus l less than epsilon. Substitute the values. So x square plus x minus 2. What are the factors? X minus 1, x plus 2. So this is mod of x plus 2 into mod of x minus 1 less than epsilon. Mod of x plus 2 is greater than 1, right? Because limiting value is 1, x is very close to 1. Now if we take delta equal to epsilon, I can say that 0 less than x minus 1 less than delta implies what? Mod of fx minus 3 less than epsilon. So this is the end of fourth one. I think we have completed all the sums. Only one part is left. I haven't explained that proof, but most of the students have left because some students have other lecture. So we'll discuss that proof tomorrow. Tomorrow I'll again explain the significance of this epsilon and delta. Okay. And then we'll start the next topic, that is continuity.